Hello everyone. Welcome to day 64 of Learning Data Science. And today, basically, what we are going to do, um, I'm going to further discuss about linear regression. Basically, the concept of the graph means like how you will plot those, right? Uh, in my previous video, if you have been following this series, so you can see that we have already discussed about cost function and all those things, right? So right now what we will do, we will just simply do a quick overview of that, and then we will jump into the graphical representation of such, right? So basically what we have learned in linear regression, what do you mean by linear regression by itself, right? What do you mean by linear regression? So this is ML. Okay, if you are learning any ML, right? This is ML. And again here, there is supervised learning, and what is the another thing? Another thing is there is unsupervised learning, right? Okay. There is unsupervised learning. So again, in supervised learning, what type of problems we solve? We solve regression, and also we solve classification. Classification, right? So basically we solve this type of problem in supervised learning, right? So again, what do you understand by supervised learning? Where input feature is given, the input variable, the input feature is given. Okay. The input variable is given, and you have to find what you have to find. You have to find output. You have to predict the output. Output is not given, right? So basically, this is what we have discussed about. And also in linear regression, what we are going to do, we are in regression, what type of data sets or what type of data you deal with, right? So in regression, it always it's done by continuous data, right? We deal with continuous data. Okay. We deal with continuous data, right? We deal with continuous data. And again, what we have discussed all things, what do you understand by linear regression, the term itself, right? What we are basically to do that, what problem we are solving and how we are solving, right? So in regression, if you had went through that video, I've told you, right, in linear regression, we predict the best fit line. So what's the use? In that, we predict best fit line, right? We predict best fit line. Okay. And how we are going to predict it, right? So basically, these things you have to understand that, for example, this is my predicted point. You can see the yellow dots. The yellow dots are my predicted points. And for example, this dot, okay, this blue line, these blue dots. Okay, what you can see, these are all the predicted actual points, right? So again, how we are going to find this line? Okay, so all of you have already studied y is equal to mx plus c. And what is y? Y is basically the slope here, right? Mx plus c. So y is basically slope. And how can we write this? We can write by y hat. Y hat is equal to mx plus c, right? See, we can write this also. And what is this y hat? This is nothing but the predicted points. What is this y hat? This y hat is are the predicted points, the yellow points. So for each particular point, if you would understand that here what we are going to do, we are predicting the slope of each particular point. Similarly, for different particular points, okay. So for n points, for n point, what will be the equation of line? So it will be my y hat is equal to m1 x1 m1 x1 plus m2 x2 m2 x2 till where? Till where? Till we are finding till mn xn, right? Mn xn, and at the last you can write it plus c. C is nothing but, so what is c? C is the intercept. Intercept. C is nothing. C is what? C is intercept. Okay, right? So what is this m1 x1? M1 x1. This is the slope. Slope. What is the slope of this yellow point? This yellow point. This is my 1, right? This is my 2. What is this? This is my 3. And what is this? It's my n. Okay. Or let me like this. Write like this. Let me put dot here. Okay. So what is this basically? What is this? What are these? Data points, right? These are nothing but my data points. These all things you can see. M2 x2, right? Similarly for m1 x1, mn xn, right? So basically these are all the same data points which I am referring to, right? These are all my same data points which I'm referring to. This one dot 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 and one dot 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 till endpoints, right? And if we will write it according to the hypothesis, right? Because at the end, whenever we are creating something or something here, particularly the ML, the model which we are creating. So what's the most important thing here? What we are doing? We are basically splitting our data into train and test, right? We are training our data. We are training our data. And where is this train data going, right? It is going similarly to the hypothesis, right? So basically this will be my hypothesis. This is my hypothesis, right? This is basically circle. Hypo. Okay, so basically this is my hypothesis. And with the term of hypothesis, how we will write these points? Okay, let's consider this C. Let's consider this C as theta naught. This is my theta naught. And what are this one? These things. This is my theta 1, theta 1. Similarly, this is my theta 2, theta 2. And what is this? This is my theta n, right? This is my theta n. So, and instead of y, what I will write? Instead of y, I will write, h of theta. My h theta is nothing but y hat. And sorry, my mistake. What I have done, it's not instead of x1, it's basically instead of y1, m1. Instead of m1, it's my theta. Okay, so do here one correction. Okay, this my theta points are nothing but the slope m. This theta are nothing but slope. What is this theta? They are slope. What they are? They are nothing but slope. These are slopes. Slope. These are slope. Mx, mx. These are nothing but my slope, right? This theta 1. This is my slope. So instead of this equation, how we can simplify and write it? Okay, how we can simplify those? We can write here h theta of xi is equal to my this theta naught plus theta 1 x1 plus theta 2 x2 till where till theta and xn. And what are these x? What are these x? These x are nothing but the data points. This x1, x2, x3. Basically, this and 1, 1, this. Okay, this one and similarly for this, what will be there? It will be my xn, right? For this particular n, what is this n? This n is nothing but this, right? So what you have understood here, okay? What you have understood, what will be the final equation for this, right? What will be the final equation for all these if we write it according to the hypothesis, right? If we will write according to hypothesis, so what will be my final equation? I will write like this. My h theta of x xi is equal to my theta naught plus plus theta 1 x1 plus theta 2 x2 till where? Till theta and xn, right? It will be plus sign here, and similarly here will be dot till theta and xn. So basically this, what is this? This is my final cost function. And with the help of this, what we're going to do? We are going to find the best fit line. That's the basically thing. Okay. And this h theta, xi, theta 1, theta naught, theta xn, what we write it? How do we denote it? Right. So basically we denote it by j in bracket theta naught plus theta 1, right? So basically, this is my cost function. This is nothing. This is my cost function. And in linear regression, what is our ultimate goal? What is our ultimate goal in linear regression? Our ultimate goal is only to find cost function, because by finding the cost function, you can predict it that what will be the best fit line, right? So here we have stopped it, right? Now, what we'll going to do, we will just understand it by graph. So I hope you have understood that in linear regression, what we are basically doing, we are finding the cost function. Okay, this is my line. Okay, this is my best fit line, and this is y is equal to mx plus c, or just write it h theta of x is equal to theta naught plus theta 1, theta 1 x1, right? We are basically writing this for one particular point. I have made you understand that y mx plus c is for that one particular point. And this theta 1, what is this? This is nothing but slope. This is slope. This is slope. And what is this? This will be my predicted point, where my predicted point will be, and this is nothing but basically y. This is my y only, right? This has theta of x. What is my y? Okay. So just let's assume my theta naught. Let's assume my theta naught is equal to 0. Okay. And slope, my slope is equal to 1 here, right? So if we will plot this point, if we will execute this line in y, so what it will be there for the first, it will be y is equal to 0 plus 1x, right? So basically, here is my x. So similarly, y is equal to x. So somewhere or the other here, it will be the point. Here will be the point. And let's not create a line basically here. We are basically predicting the points, right? So here is my x1, x1. Here is my x2. Here is my x3. Here is my x4. Here is my x4, right? So here it will be similarly my y1. It will be y2. It will be y3. It will be y4. Okay, so one thing, this will be my point, right? It's same, similarly, right? So these are all my points, and basically what will be my, these are my predicted points, right? So for example, my, this is my actual point, this is my actual points, okay? So what we're going to do, we are going to find the difference of it, and difference, what we call is as sum of residual, right? Sum of residual, SSR, we call it this. And what is my cost function? The cost function basically is the differentiation of this, means like the distance which we are calculating, right? So in cost function, what we are doing it basically, right? So we are subtracting this point with this point, right? So how it will be in cost function, what it will be, y hat minus y whole square. Why what we are doing a square? We are doing square because this value might be negative, right? The distance might be negative. So basically this is nothing but distance, okay? And here my n is equal to the number of data points. So what I will do, I will divide by n, right? And what will you do? We will do summation of my sorry, here I is equal to 1 till where? Till n. And we are dividing it by 2. Why are dividing it by 2? Because differentiation of what is y? What is y basically? The rate of change of x. Okay, that is only y, because y depends totally on x, the rate of change of x. If we'll change the value here, slope, okay? If we are changing the value here, right? For example, the value of slope, let's take, okay, not slope, basically here x1 is there, right? So initially my value was 1, so 1 into 1, right? And here my value is 2. This is 2, x is equal to 2. So what y will be? Y will be 0. Y is 0 because theta naught value is 0 and slope is 1. So 1 into 2. So how is y changing? Y is changing with respect to x. So that's what we call differentiation. dy dx, dy dx of x square. So dy dx of x square, if you learn differentiation, here it will be 2x. So for that particular reason, this 2 and this 2 might will get cancelled for that reason. And this is basically my cost function. This is nothing. This is my cost function. And instead of y hat, what you can execute? You can execute this line. Theta naught plus theta 1 x1 here. Here. You can execute it like this. Theta x is equal to minus y. Okay. Whole square divided by 2n, and till where? Till be summation till n, and I is equal to 1. So what will it will happen if we'll change the theta 1 value, okay, the slope value, if we will change it, right, from 1 to 0.5, okay, from 1 to 0.5, okay, we are changing the value, to 0.5. So now let's execute it. What will be my y value? What will be my y value? My y value will be x is 1, okay, and what is theta 1? Theta 1 is 0.5. So similarly 0.5. So what it will be? Y will come somewhere around here. So if we will execute this, you will get a line like this. This will be the new predicted line. This is nothing but new predicted line. And similarly, if you will execute the values here mean the actual data points. Actual data points, you know the value. And here is the predicted data point. And here is n is number of terms. Okay. Number of terms. Number of terms. Number of terms is my n. So what is number of terms basically here currently? You can count one, two, three, four. So here it is four. So how will you create the j theta graph then? Okay, so this is my new graph. Okay, this is my new graph. And here what it will be there? It will be my j theta. J theta. And what is this basically j theta? J theta is nothing but our cost function. J theta is nothing but our cost function. If you look previously I have only told about this. I told about theta x and theta slope. For that reason, what I will do, I will just crop the video of that, and then you can understand. Okay. So what cost function is that? This is my cost function graph, right? And we are going to plot it, right? So what will be the value? Let me remove this. So now what will be my value? What will be my j theta value? Okay. What will be my value? Okay. Value will be 1 by number of terms was 4. So 4 into 2, 4 into 2. And here y hat minus y. Okay. So similarly for the first predicted point, what was my y hat value? Okay. My y hat, my this will be into. Okay. And what was my y hat value? My y hat value was, for example, say 1. Not example. Previously we have calculated how when slope was 1, how our y value changed. So it will be 1 minus my predicted point. Uh, Predicted point minus my actual point, right? So 1 minus 1. Similarly here it will be 2, and so on. If we will execute this value, okay, you will get some points of j theta naught. And what is this? This is nothing but my x. Okay, this is nothing but my x. So the value, if we will execute this equation, so you will get the graph like this somewhere around. You will get the graph like this. You will get a point here. Okay. Similarly, for every point, you will get point like this, point like this, and if you will connect these points, okay, so what you will get? You will get a parabola type curve. This is nothing but this is my gradient descent. This is gradient. This is my gradient descent. Okay. So So this is my gradient descent, and in gradient descent, what we are actually finding? We are actually finding this. This is my local minima. Local minima. Okay, we are basically finding this. Why? Because you will might get a point here, right? And that might not be the okay. So basically, what we are going to find here, we are going to find the local minima. Why? Because at the end, we have to locate our best fit line, right? And where that best fit line should be, that local minima is doing. This is very important concept. Try to understand, right? In linear regression, what we are doing, we are going to find the best fit line. We have found, okay, this should be the best fit line. But you can find many best fit line is there, right? Uh, Someone will say that my best fit line will be here. Someone will say my best fit line will be here. Someone will say here. Someone will say like this. Someone will say like this, right? So this will my everything is best fit line. So these are the points. These are nothing. These are the points where they are cutting it here. The slope here. These are the points. These are the only points. These are the best fit line. So how we will decide what best fit of line should be there. So ultimately our best fit line should be here. My best fit line will be should be here. So for that, what we need to do? Obviously, if we are getting here our point, so we will try to move backward, right? So this is the most important concept which we are learning, right? You will definitely need this concept in neural networks, right? So similarly, we are trying to move closer to the best fit line. Okay, we are trying to move closer, and for this particular thing, there is a convergence theorem. Convergence convergence theorem. So basically what theorem? So basically, excuse me. So basically what this convergence theorem is doing, with the help of this convergence theorem, we will help to locate the local minima. Okay, and what is the syntax for this? Okay, so we'll be doing here x minus alpha, and my x minus alpha, and within alpha, what we'll be doing, we'll be writing here d by dx, of nothing but of h theta, not basically h theta, but my j theta, the cost function, j theta naught theta 1, theta 1. And what is this? This is nothing but my cost function, my cost function. And what is this alpha? Alpha is basically my learning rate. Okay, and while deciding alpha, make sure that alpha value should be very, very less. The value of alpha is very, very less. It should be somewhere around 0.0000001. So this should be my alpha value. Why so less alpha value? Because if we'll take a large number, so it will jump like this. It will jump like this. He will not get a local minima. So for that reason, we are taking the low value of alpha, very small value of alpha. So let me summarize quickly what we are doing in linear regression. In linear regression, we are finding the best fit line. Okay. And how we are finding the best fit line? We are finding the best fit line with the cost function. And again, where should be that best fit line? How we are going to decide which will be the best fit line, right? With the help of gradient descent and with the help of local minima, right? And the convergence theorem I have showed you. So here we are completing linear regression, right? And day after tomorrow or tomorrow we will start with the new series, and that will be of logistic regression. There we will discuss about how we can solve the issue of gradient descent further, right? So we will start that in our logistic regression. So we will discuss it there. Till then, goodbye. Take care. Jai Hind.